Okay, so over the past several weeks, we've discovered and used the Pythagorean theorem. And the Pythagorean theorem is used to find missing side lengths of a right triangle. Again, we're working with triangles that are right triangles or have a 90-degree angle. And the original formula is a squared plus b squared equals c squared, which is like saying the leg squared plus the other leg squared equals our hypotenuse squared. And we also discussed last week that if you're missing a leg, then you would be subtracting the hypotenuse square and one of your leg squares to find the missing leg. Okay. Now, this week what we're going to be doing is we're going to be applying the Pythagorean theorem to different situations. And basically, you're going to need to identify right angles in different shapes or different pictures or different situations, and then use the Pythagorean theorem to solve the problem. Sometimes you may have to use the Pythagorean theorem more than once. Now today what we're going to focus on is Pythagorean theorem in three-dimensional shapes. So let's go ahead and take a look at the next page. So here we have two different shapes. We have a rectangular prism on the left side and a cube on the right side. And you can see that the rectangular prism has the three dimensions of length, width, and height. And the cube also has length, width, and height, but what makes a cube special, of course, is that all the edges are the same length. And that's going to help us out as we go through and do a couple of these problems. So the first problem we're going to take a look at today is dealing with the cube. And then the second problem, we'll take a look at a rectangular prism. So let's go ahead and turn the page to our first problem. So, the question asks, how do you find the length of the red line segment inside the cube? Now, of course, we don't have colored paper here, but this line right here is our red line segment. And it starts at the back top right corner of the cube and comes all the way through to the front left bottom of the cube. So it's kind of this diagonal that goes right through our cube. And again, because we're dealing with the cube, I know that all of these edges are the same length. So if this side here is 5 inches, then this edge is 5 inches, that edge is 5 inches. So that's going to help us out in finding the distance of the red line. So what we're going to use is the Pythagorean theorem. And of course, to use Pythagorean theorem, we have to deal with right triangles. So what I can notice is if I kind of cut this box down here, and you'll see what I mean when I draw the picture, you're going to see a right angle appear. So if I can draw a dashed line here, go ahead and you can do this on your paper as well. From this front left to this back right, you'll notice I get a right angle. This is going to be a right angle here. Okay, but the problem is, right now I don't know what this length is. I know that this height is 5, but I don't know what this length is. So I can't use Pythagorean theorem at this point in time to find the distance of the red line. So what I kind of have to do is I have to work backwards. I now need to figure out, well, what is the distance of this dotted line? Well, if you notice, it is made up of a right triangle using the cube. And here's my right angle here. And I know the length of these green lines because, again, we're dealing with a cube. I know that that is 5 and that is 5 as well. So now I can use the Pythagorean theorem to find the distance of this blue dotted line, which eventually is going to help us solve the problem. So I'm going to go ahead and use Pythagorean theorem. I'm looking for the hypotenuse, so I'm going to be adding. So I'm going to take 5 squared plus 5 squared. So 5 squared is 25. 5 squared is 25. 25 plus 25 is 50. Therefore, the blue line is the square root of 50. Now you can go ahead and change that to a decimal if you wanted to maybe be 7.1, but I'm going to leave it as square root of 50 right now. If you choose to change it to a decimal, that's fine. But you'll see why I leave it as square root. It's a little bit easier in the long run here. So now I have this distance here is the square root of 50. And I know that this height here is 5. So I've got two sides of this right triangle, to find the red line. So again, I'm going to use the Pythagorean theorem again. As you'll see in a lot of these problems, you're going to do the Pythagorean theorem more than once. So I'm going to do this again here. So I'm now going to take 5 squared plus the square root of 50 squared. So 5 squared is 25, and from our previous units, I know that the square root of 50 squared is just 50. 25 plus 50 is 75. The last step in a Pythagorean theorem problem is take the square root. The red line's length is the square root of 75, or 8.7. Okay. So again, just to kind of sum up, what I'm trying to work with is some right triangles. And in this case, to find the dotted red line, I'm sorry, not the dotted red line, but the red line, I've got to do the Pythagorean theorem twice. Once to find the bottom part or the base of this right triangle, and then to use Pythagorean theorem again to find this right triangle. So I got this triangle down here, and then you could say this triangle that cuts right through the box. Okay, so let's take a look at a rectangular prism here. So take a look at the next problem. Okay, so again we have this red line. Oops, wasn't the best red line there, but anyways, it starts at the top left back of the box, comes all the way to the front right corner of the box. So they've given us some of the dimensions of the box. Now, if I go ahead and kind of draw this right triangle here, okay, I'll kind of shade it in, maybe it'll make it appear a little better. It's like a slice of a right triangle cutting through that box. Now, unfortunately, I do not know the distance of this dashed line. I do know this height. This height is 4. I get that from here. But I don't know what this dashed line is, so I don't have enough information yet to find the red line. So like we did in the previous problem, I can then kind of find another right triangle. Well, you'll notice here is another right triangle, with the blue dotted line being the hypotenuse. So here's my right angle here. And I do know the dimensions of these orange lines. This front part is 7, and this, I'm sorry, not dash line, but this line back here is 3. So I now have my two legs, which are 3 and 7. I can go ahead and do the Pythagorean theorem. So I'll go ahead and do that. So it's going to be 3 squared plus 7 squared. So that's 9 plus 49. 9 plus 49 is 58. Okay, and the square root of 58, if you'd wanted to use the decimal value, it would be 7.6. But again, I'm not going to use the decimal value. I'm just going to use square root of 58. So this blue dashed line here is the square root of 58. Okay, so now I have two sides of my right triangle. I have this leg, which I get from 4 feet, and I just calculated the dashed line to be the square root of 58, or 7.6. So I can now find the distance of the red line by using my Pythagorean theorem. So I'm going to go ahead and do that right now. So the square root of 58 squared plus my height, which is 4 squared. So square root of 58 squared is just 58 plus 16. 58 plus 16 is 74. And the last step of any Pythagorean theorem is to take the square root of 74. And again, you could leave it as the square root of 74. This red line is the square root of 74, or the decimal value is 8.6 feet. Okay. So again, very similar to the cube. I just got to do the Pythagorean theorem twice. Once to find this dashed blue line, and then once you get the dashed blue line, you can go ahead and calculate the red line. Okay. So let's take a look at another shape. Okay, we're going to take a look at a pyramid next. So here I have a pyramid, and in this case, we are going to have to find the slanted side of the pyramid. So I want to know, what is the length of the slanted outside of this pyramid? Well, you notice I've got a right angle here. I've got another right angle here, which we'll talk about later on. But for right now, I'm just focusing on finding this dashed line. Now, a couple pieces of information. I know that the base of the square pyramid is 16, which means all these sides are 16. So 16, 16, 16, and 16. Now you'll notice the height of the pyramid goes right down into the middle of the square pyramid. So from this point to that point is halfway through the pyramid. So if it's halfway through the pyramid, I know that this distance is 8. And according to this right here, I know that the height is 8. So I have two legs of my right triangle. So to find my dashed line, again, I'm going to use the Pythagorean theorem. So that's going to be 24 squared plus 8 squared. And then go ahead and use a calculator if you need to. 24 squared is 576. 8 squared is 64. Add those two guys up. You get the square root of, you get 640. Do that again, 640. And then to find the length of the red line, take the square root. So it's either the square root of 640 or 25.3. Okay. Now, you might come across another pyramid question similar to this, and they might want to know what is the height of the pyramid. So we'd use some of the known sides to find the height. Okay. Sometimes they may want to know, well, what is the corner length of this pyramid? Okay. Well, you notice again we have a right angle, and because it comes halfway through the pyramid, you'll notice that this point is 8. We just calculated this length to be 25.3. So I would do 8 squared plus 25.3 squared to find the corner edge of the pyramid. So again, you're doing the Pythagorean theorem multiple times. Just try to find your right triangles to do that. Okay. So moving on to our last picture is the cylinder picture. So go ahead and take a look at the last picture. It's a cylinder. Now again, we want to try to find the diagonal of the cylinder. And I know your picture doesn't have any dimensions, but I'm going to go ahead and fill these in for you. So the height of our cylinder is 20 inches, and the diameter of our cylinder is 10 inches. So go ahead and take a minute or hit pause and see if you can find what is the distance of the dashed line or the diagonal of the cylinder. So go ahead and do that. Hit pause. Okay, so again, we have ourselves a right triangle. So I can use the Pythagorean theorem. As you'll see, this theorem comes in handy a lot. So I'm going to go ahead and do 10 squared plus 20 squared. 10 squared is 100. 20 squared is 400. 100 plus 400 is 500. Square root is 500, which is then 22.4 inches. So that's how long the dashed red line is. Now, when you come across cylinder problems, sometimes they'll give you the radius. So, for example, they would say that the radius of the cylinder is 5. Well, then the radius is half the diameter, so you would just double that to get 10. Okay, and just to kind of give you a heads up, some of the problems that you might see, they may give you the diagonal. You have to calculate the height, or you have to calculate the diameter. Again, you're just manipulating the Pythagorean theorem. In that case, you're looking for the leg, so you would be subtracting instead of adding like we've done in the previous problems. Okay. So go ahead and take a look at the last 2 pages of the worksheet. You'll see that there are 8 different 3-dimensional figures. Do your best to answer these as best you can. Again, you're trying to most likely use the Pythagorean theorem either once or twice in each problem. Answer the quiz following this video, and the answer key for this worksheet should also be posted somewhere on Schoology as a method to help you out, or just to check your answers as you go. Okay? All right, good luck.